start again. It's a rich thing.
In this session, we are going to learn about bitwise operator. In Python, bitwise operators are used to performing bitwise calculations on integer. The integers are first converted into binary and then operations are performed on bit by bit. Hence the name bitwise operator. Then the result is returned in decimal format. So first of all, we will learn some concepts of binary number system. But note that I am not going to discuss all the concept of binary number system. Rather, we will learn some of the topics which are required to understand this bitwise operator. So our first point is conversion of a decimal number into binary number system. To convert a decimal number into binary, we need to repeatedly divide the decimal number by 2 until we get 1 as the quotient. So here we have 50, and if we divide it by 2, then we will get 25 as the quotient and 0 as the remainder. Again, if I divide 25 with 2, then we will get 12 as the quotient and 1 as the remainder. We need to repeatedly divide it by 2 until we will get 1 as the quotient. So again divide this 12 by 2, which will return 6 as the quotient and 0 as the remainder. Now divide this 6 by 2 and now we have 3 as the quotient and 0 as the remainder. Again divide this 3 by 2, then we will get 1 as the remainder and 1 as the quotient. So we got our quotient as 1, which means we need not to divide it further. And we need to note down the answer like this manner. So the answer will be 110010, and these each digits are known as bits. So the next point is conversion of a binary number into its equivalent decimal number. So let's take this binary number, and first of all we can index these each digits or bits from right to left like this way. Here we need to follow one formula, that is binary bit multiplied by 2 to the power index value. For example, here we have the binary bit 0, and now we can write 0 multiplied by 2, and the power of 2 will be the index value. In our case it is 0. Similarly, we need to do it for all the bits like this way. Now add them up and we will get 50 as the answer. So 50 is the decimal value of 110010. Now the question is, how many binary numbers can be represented by 2 bits? So by using 2 bits we can represent up to 3 like this. And the formula is 2 to the power number of bits minus 1. For example, by using 8 bits we can represent up to 255. Our next topic is ones complement. For example, here we have this binary number, and if you want to find the ones complement of this number, then you need to just flip the bits, and this is our answer, or 1100 is the ones complement of 0011. Next we need to learn the addition process of binary number system. But before that, you need to keep these points in your mind, that if you add 0 with 0, then the sum will be 0 and also the carry will be 0. Or if you add 1 with 0, then the sum will be 1 and carry will be 0. And finally, if you add 1 with 1, then we will get 0 as the sum and 1 as the carry. Keep these 3 points in your mind. Now we have 101 and 010, and the addition will start from right to left. So first of all, we need to add 1 and 0. Then we will get 1 as sum and 0 as carry. Next we have 0 and 1. And if you add them, here also we will get 1 as sum and 0 as carry. And finally, we have again 1 and 0. So we will get 0 as the carry and 1 as the sum. So the answer is 111. Now let's solve another problem. So here we have 1010 and 1111. So if we add 1 with 0, then we will get 1 as sum and 0 as carry. Next we have 1 and 1. So if we add 1 with 1, then we will get 0 as sum and 1 as carry. Now this carry that is generated here, we need to add this carry with the sum of these next two digits. So if we add 0 with 1, then we will get 1 as sum and 0 as carry. But note that we need to add this sum with the carry that is generated in the previous 2 bits. So if we do so, then we will get finally 0 as the sum and 1 as the carry. And then we need to add 1 with 1, and again we will get 0 as the sum and 1 as the carry. But note that we need to add this sum with the carry that is generated in the previous bit, that is 1. So if we do so, then we will get finally 1 as sum and 1 as carry. Now we don't have any bits, so this carry will set here like this way. So the final answer will be 11001. So our next topic is 2's complement. For example, here we have a binary number that is 0011, and if you want to find the 2's complement of 0011, then you need to first find the 1's complement like this, and then you need to add 1 with this least significant bit. So the 2's complement of 0011 will be 1101. So this is our answer. Now I have told you few minutes back that by using 8-bit you can represent 255 different numbers uniquely. But that was true for unsigned number. If you try to represent a binary number with sign, then you need to give one bit to represent the sign. Here this first bit or the most significant bit represent the sign. If it is 0, then the next 7 bit will represent a positive number, or if it is 1, then it will represent the negative number. Now if one bit reserved for sign, then how many distinct number you can represent by the next 7 bit? So for the sign bit, the formula will be 2 to the power number of bits minus 1, and then again minus 1. So by using 8-bit, we can represent 128 positive distinct number and 128 negative distinct numbers. Next question is how these numbers will be stored in memory. A positive number like 39 will be converted into binary sequence like 001, 00111, and then these binary numbers will be stored in memory. But for a negative number like minus 39, the picture is quite different. The binary sequence of 39 is not going to store in memory. It will first convert 39 into its binary sequence, and then it will calculate the 2's complement of 39, which is going to store in the memory. So this is how a negative number stores in memory.